Hi, I'm Mike Bernstein and I'm the VP of R&D at Mestrolab. A few months ago at the ENC in Boston, we had in our booth the Raspberry Pi running Mnova software, and in fact we had a competition where every night somebody won one of these units to take home. What I'd like to do today is to show you this and show you and describe a little bit more of how it all works and integrates. Now, Mnova itself you will know and I'm sure love as a vendor-neutral software that supports multiple platforms. So you can run this on the Windows family of environments all the way up to Windows 8.1, the Mac OS environment up to Mavericks, and on a number of Linux distributions running on an x86 Intel processor. So, what are we trying to do today and why are we trying to do it? Our motivation behind running it on this platform was to see A, whether it could be done, and B, how fast it would run. So this isn't really a serious attempt at moving the product onto the Raspberry Pi environment. It's more of a feasibility study, if you like, or an engineering check. So please view it in that light and give us a little bit of leeway, as this is not really intended to be a serious product investigation at this point in time. So what I've done in the last few minutes is I've built the unit, so to speak. So this is what I'm going to be running on in the next few minutes when I start showing you the screen and how it all works. Okay, here we go. You can see the screen obviously, and there's nothing on it yet. And I've got everything connected now. And what I'm going to do is put the power supply into the unit, and you can see it doing its power on self-test. So here we go. It's booting the system. As I mentioned, I haven't done any overclocking of the system, or even though that is very, very feasible and easy to do. I've set it up so that it boots straight into its X environment, which is called Lumix, and that provides you with quite a few of the standard features that you need to basically run in a very familiar environment. If you prefer using the command line interface, then that's absolutely fine. I'm sure once this is up and running, you'll find this really quite familiar. Here we go. It takes a few seconds. What I'm going to do is I'm going to show you some pretty typical stuff. So I've got some data, a bunch of data from brucine and chloroform. I'm going to show you a few manipulations on that. And then I've got some reaction monitoring data, and I'm not going to spend a lot of time with that, but I'll just show you basically how that looks. So we're presented with a very familiar screen if you're used to Mnova. It's all basically very much as you're used to seeing. And if I do File, Recent Documents, and I go to the brucine data, it's got to pull all that data off this SD card, which will take a few seconds. In here I've got a proton, carbon spectrum, COSY spectrum, and an HSQC spectrum on the bottom. Now this is actually working with the scripting environment of Mnova, and I'll show you that in the sense that I'll run a script for you, and this is one that we all love, which is the following. What I'm going to do is I'm going to, on that I've already determined the multiplets for this spectrum. I'll show you how I can copy those multiplets report to the clipboard. I can then go to scripts and run multiplet report to spectrum. In here I can paste what I had. That goes into this table over here, which is running off the page. And what I can do now when I click on OK is it's going to read that table and generate a simulated spectrum of brucine, excluding the chloroform and the water peaks. And I think that's really quite usable in terms of speed. Let's come back to the real spectrum, this one over here, and just to show you how quickly things work, I'm going to remove all of this analysis and I'm going to reanalyze the multiplets using the automatic one. So this has to do a peak picking first, and then it has to assign the multiplets, and there you go, it's done that. That's how long it took. Not too bad at all. I'm not using GSD peak picking at this moment because that really does slow it down, and that takes well over a minute to execute on this spectrum of this complexity. However, if we go to the carbon spectrum, here I am using GSD peak picking. So if you look in the peak picking options, you can see that I can change that to GSD, and I can ask it to peak, or automatic peak picking. There we go. That's not too bad, really. So there's our carbon spectrum GSD peak picked. I can adjust the vertical scale. I've moved the mouse wheel, and that's why it suddenly froze there. But I could do baseline correction here. I've done it already, so it's not too obvious. Let's have a look at the cozy now. This is misphased in the F2 dimension, so let's do the automatic phasing on that. So if we go to processing, phase correction, automatic along F2. There we go. And just to show you that I can zoom and do things like that. It's obviously not going to be lightning fast for this type of thing, but whether it's usable or not is something that you can decide. I think it's not too bad, all facts considered. And I'm showing this as a bitmap, and if you wanted to show this as a contour plot, which is the standard way to display these things, it looks like that. And that just gets a bit slow if you want to zoom that up and down or expand that up and down. So let's move it back to a bitmap plot, and we can go down in intensity. And that's reasonably usable. Lastly, let's have a look at the HSQC data. I'm not going to do any analysis of this, by the way. I'm just basically showing you processing. And what I'm going to do for this data set is show you the F1 stripe reduction, which is, I think, a really nice feature. So if we again go to processing, and I go down to reduce T1 noise, what you'll see is the stripe for the methoxy peaks around 4 ppm. You'll see those stripes disappear in a few seconds. There we go. And let's just drop the intensity just to make it look pretty. There we go. So this is typical data for small molecules, and I hope you'll agree that this is a fair amount of data for it to work with, and it's dealing with it quite well. So my second example is that of a hydrolysis reaction where we've monitored the hydrolysis as it occurs with time. So let's open up a new page and read in the data. Now I've got about 60 time vectors here, like that. And these are each 16K in size. So these are going to load in, and these have to come off the SD card again. Here we go. And you can see that I've previously selected two regions, one for the starting material here, which is represented by this peak over here, and this is the product, which is represented by this build-up curve over there. And just to give you an idea as to performance, I'm going to ask it to show me the full spectrum, which is that button. And I'm going to now zoom in on a different region just to give you an idea of the graphics performance. So let's have a look at here, for example. But this is just to demonstrate a little bit of this, and I'm going to leave it at that as far as the Mnova demonstration, and I hope this has been useful to you in showing you the basic performance of Mnova running on a very standard Raspberry Pi system. Right, that's it. I hope you enjoyed that. That was showing you Mnova running on the Raspberry Pi. As I mentioned, this is really a technical exercise. It's not designed to do anything other than illustrate the fact that we've got some good deal of versatility in the way in which we can operate with the software. You probably know that we base the software on the Qt libraries, and this gives us this flexibility to operate on multiple platforms and with multiple operating systems. And this is just another example of how we can leverage that flexibility into something which is really just a bit of fun today. So I hope you've enjoyed it. You'll find on our LinkedIn page that I've got a bit of a discussion going there with regard to Raspberry Pi. And should it occur that you play around with this and you find something interesting with regard to NMR, then please post it for us all to have a look. And I'm sure that a number of people will enjoy seeing that. So thank you very much for watching this, and I hope you have a lot of fun, and I hope that you use Mnova, and it's very useful for your research. Thank you, bye.